Traditional structural engineering workflows can involve a variety of challenges. Structural engineers typically start the design process by getting familiar with the architect's design, by interpreting architectural drawings or general 3D conceptions. Because the structural designer or engineer creates both the physical and the analytical model concurrently using Revit software, the data can be entered once and used for different purposes. In this example workflow, a structural designer creates the physical and analytical model and exchanges these designs with a structural engineer, who runs analysis to check safety conditions and to perform optimization. Rather than working in siloed systems, they both can use BIM 360 Docs. BIM 360 Docs integrates the entire project workflow from design to construction across one common data platform. Structural designers can use the Publish Settings tool in Revit to select views and sheets of the model to publish them to the cloud. These selected views and sheets are automatically extracted in the BIM 360 Docs environment to give extended teams easy and instant access to the project information via web or mobile. Then, the extended team of structural engineers can easily review what has been done in Revit and the current state of the structural project. When project teams have the right information at the right time, work happens faster. BIM 360 Docs lets them publish, manage, review, and approve all drawings, documents, and models, anytime, anywhere. The project teams can not only review all information, but they can also download project files. With access to the project data, a structural engineer continues the design process by performing structural analysis and running code-checking optimization. The Revit analytical model can be sent to Robot Structural Analysis Professional with all the information needed for structural analysis, including boundary conditions and loads. In some cases, the engineer may also decide to make changes to the model prior to analysis, based on their experience or access to advanced simulation tools. For example, the wind load simulation feature lets users simulate wind flow around a structure and generates wind loads automatically. Once the analysis has been conducted, the engineer can easily explore the results and begin designing structural elements. Robot Structural Analysis Professional is a powerful tool not only for calculations, but also for visually exploring results. With multiple ways of presenting analytical results and the ability to easily access them, structural engineers can very quickly prepare the final structural documentation for review by project stakeholders. Next, the structural engineer can run code checking of the structure to verify and design steel members based on a wide variety of national and international codes. The first step in designing structural steel is to organize the bar elements, beams, columns, braces, etc., into member groups. Each member in a group will be assigned the same section by the design process. The engineer can also select optimization criteria. Once the design group is optimized, a simple Change All button allows all new sections to be applied to the model. When design changes and analysis have been completed by the engineer, the information can be brought back into BIM 360 Docs to allow the designer to review the design changes and update the physical model accordingly. Here, structural engineers can upload their structural analysis and code-checking documentation in the PDF file format. Results can be easily stored and explored in the Revit environment, enabling users to explore and document results and make effective design decisions. Once the Revit model has been updated after the analysis and code-checking process, the structural engineer can upload a new version of the Revit project to BIM 360 Docs. Then, the structural designer can access the updated optimized model by the structural engineer via BIM 360 Docs. Using the Compare tool, the structural designer can get insight into what has been changed in the model. BIM 360 Docs has integrated change visualization that lets users compare the changes between two selected versions of the project. This summary provides a quick overview of changes made by the structural engineer during the code checking process. With BIM 360 Docs, structural teams can manage 2D plans, 3D BIM models, and any other project documents. This streamlines the connection between design and fabrication.